If you use virtual machines or containers, and particularly if you use virtual machines and containers, then this may be of interest. It's called Harvester, it's open source, and although it's intended for the data center, in some ways it might be the ultimate server for your home lab. What is it? It's a Kubernetes-based hyperconverged infrastructure, and yes, that was a buzzword salad, so let's convert it to something closer to English. Kubernetes is for running containers at scale. If you want to run a container on your computer, you'd use something like Docker or Podman. If you want to run lots of containers across lots of machines in a data center, then Kubernetes is the industry standard way to do it. Hyperconverged infrastructure combines virtualization, storage, and networking into a single physical server. And to scale it out, you just add more servers in a building block sort of approach. I will link videos below that do a more complete job of introducing the concepts of containerization and hyperconverged infrastructures, but the takeaway point here is that Harvester handles containers, virtual machines, storage, and networking, and it does it in a way that can work at anything from data center scale right down to just one physical computer. You can of course run containers inside virtual machines on a single computer, but Harvester can run them on bare metal, the same bare metal that runs your virtual machines. To be clear about this, when I say containers, I mean proper Docker style containers. Just heading off a few Proxmox comments there because yes, it does things called containers, but LXC containers are not the same. Let's dig a little deeper though. What exactly is Harvester? It's made up of a few components. The Kubernetes distribution it uses is RKE, the Rancher Kubernetes engine from Rancher, now part of SUSE. The distributed storage layer is provided by Longhorn, also part of the Rancher stack. For virtualization, it uses KubeVirt, a project that lets you run KVM virtual machines using Kubernetes. The Harvester management interface is based on, you probably guessed it, Rancher. You might be wondering, why run virtual machines in Kubernetes? Isn't that just overcomplicating things when we already have plenty of ways to run KVM virtual machines? The answer depends on whether you are going to be running containers anyway. If you're not planning to use containers, then I would agree, this adds a lot of complexity for not a lot of benefit. If on the other hand you want to run both containers and virtual machines, and particularly if you want to run them at scale, then this provides a single control plane to manage everything using Kubernetes. That's why you may choose to do this in the real world. It all integrates with Rancher, which is SUSE's Kubernetes management platform. If Kubernetes is for managing containers at scale, then Rancher is for managing Kubernetes at scale, or just for making it more point and click. The sort of enterprise use case for this might be a main Kubernetes cluster in your data center running RKE, a smaller edge cluster on a branch site running K3s, a cloud-based Kubernetes instance in Amazon Web Services, and a Harvester cluster running your virtual machines, all managed by Rancher. That's the enterprise vision, but for our home lab use case, let's get rid of this stuff, and all I really want to do is run all of this together on a single box. To set expectations, this video is neither a review nor a recommendation. I don't think you can actually review a platform like this unless you've used it in anger, at scale, with production workloads and been through at least one upgrade cycle. I haven't. I just thought it looked interesting and figured you might too. So I'm going to show you how to get this set up and share a few lessons learned along the way. To get started, head over to harvesterhci.io, scroll down and click Download Now. This will take you to the release page on GitHub. I'll add links to the video description for your convenience. Grab the latest one. You may need to scroll down to find it, not pre-release unless you like to live dangerously. You want to download the full ISO, not the net install ISO. The net install one is smaller because it doesn't include all of the container images and will download them on demand from Docker Hub. While this may sound helpful, you could run into Docker rate limiting this way. It's intended more for organizations that have their own private container registry. Once you've downloaded the ISO, mount it via your preferred install media. I'm partial to Ventoy, but you can create a USB installer from it with Rufus or Etcher as well. Boot your machine from the install media, and depending on your hardware, you might see a warning like this. The hardware requirements here might make you do a double take, because compared to something like Proxmox, they seem pretty extreme. Proxmox requires 1GB of RAM just for testing and 2 for production, but Harvester wants 32 and 64 respectively, paired with 8 or 16 CPU cores, minimum. You may well ask, is this actually the hardware requirement for Harvester itself, or is this allowing headroom for virtual machines? because Proxmox might say it only needs 1 gig of RAM, but that's just to get it to install. You're not actually going to be able to run a workload on a host with 1 gig. The answer is complicated. Let's move on and we'll answer that later. At the next step, we're going to choose to create a new Harvester cluster. The recommended thing to do here is put your installation on one disk and choose a second data disk to store your virtual machines. But if you're tight for hardware, you can use the same disk for both. When it comes to the IP address, you'll either want to set this as static or pause and go create a reservation in DHCP now. Because once Harvester has been installed, you cannot change its IP address without reinstalling. Personally, I'd go with an old-fashioned static address so the hypervisor isn't dependent on DHCP. Because you might virtualize DHCP, and you don't really want the host to be dependent on a guest that's dependent on the host. Host name should be self-explanatory. Then set your DNS servers on the next page. The DNS servers can be changed later, but there's a specific process you need to follow to make sure it doesn't get overwritten at the next reboot. Next, you'll have to choose a virtual IP, and again I'm going to choose a static one. The difference between your virtual IP here and the management IP we set previously is that the management IP is for the host, and the virtual IP is for the cluster. In our use case with a single node cluster, they'll go to the same machine, but if we built this out with multiple hosts, the virtual IP would be a floating address to manage the cluster as a whole, and if I wanted to log into a specific host, say using SSH, then I'd use that host's management IP. The cluster token is something you'll need to join another hosted cluster if you want to scale it out later. Then you just need to choose a password, and you can pretty much skip through the rest of it. The password can be used to log in at the console or using SSH. If using SSH, the username is Rancher. You've got options for a proxy server to change your time servers, and if you have SSH keys or Harvester config prepped in a web server, you can import those here. This is more for automated deployments, but we've already bashed in the config manually. Let it install, and once the Harvester logo appears, you'll need to wait a bit longer until the status changes to ready. Once it does, your deployment is complete and you're ready to log in using the management URL shown at the console. This should be the virtual IP you chose during the install. Create a password for your newly installed cluster, and you're logged in. This isn't a guide to Harvester, but as a quick start for anyone coming from VMware or Hyper-V, before you create a virtual machine, you'll need to first define an image. Come to Images and click Create. This can be a disk image or a DVD image. I'll upload a Windows Server ISO. To create a virtual machine, come over here and click Create. I'm going to ignore these settings for a moment so we can talk about volumes. You'll notice it requires a volume that maps to an image. That's why we uploaded our Windows ISO first. In the VMware and Hyper-V world, you can mount an image via your client, but in Harvester we have to upload it. The other thing of note is the bus type here. VirtIO is the default selection, but you can also choose SATA or SCSI. VirtIO is the power virtualized option. It's more efficient because the guest VM understands that it's virtual and can communicate more directly with the KVM hypervisor. The SATA option emulates physical hardware, which means it should work with pretty much every guest operating system, but it has more overhead compared to VirtIO. The downside of VirtIO is that out of the box, Windows can't use it. You need to install the drivers first. Fortunately, the team at Harvester thought of this, and if you come up here, choose Use the Virtual Machine template and select Windows ISO image base template, it will pre-populate some options to make life a little easier. It will create a SATA CD-ROM to which we'll mount our DVD image. We have what will be our C drive. I'll make that a little larger because although it will install on 32GB, it'll run out of space after a few months of Windows updates. You'll notice the bus is set to VirtIO, and then there's another CD-ROM referencing a container registry. This is the drivers you need to get Windows talking to KVM. I'll bump up the spec a little more because these really are the bare minimums. And then one other tweak I'd suggest is changing the network interface from E1000 to VirtIO. This is like the disk thing again. E1000 is emulating physical hardware. It's going to work on all the main operating systems, but VirtIO is more efficient. Click Create and the VM should appear and switch to the running state. Now if you click on Console and Web VNC, we're in the Windows installer. Click your way through as usual, and when you get to this screen where no drives show up, click Load Driver, and then browse the second CD-ROM to the folder that best matches your version of Windows. Choose the block driver. Now Windows understands your VirtIO disk and you can install as normal. Once you're into Windows, open up the driver CD-ROM again and run setup.exe to install the rest of the missing drivers, including the Power Virtualized Network adapter. Okay, that's your virtual machines. Now what about these containers? Remember the enterprise use case I described? Harvester wasn't running the containers. The containers were in separate Kubernetes clusters and Harvester was handling the virtual machines. But Harvester absolutely can be used to host containers directly. We'll need Rancher installed to do it though. You could install Rancher somewhere else or spin up a VM to do it, but for a lab the easiest way is to deploy it using the official Rancher Manager add-on for Harvester. Although it's official, it's currently classed as experimental, so if you look in the list of add-ons on the advanced menu heading, you won't see it by default. I'll link the documentation below, but all you need to do is log into your Harvester command line using either SSH or at the console and copy paste this line from the documentation. If you're using SSH, you'll need to switch to root first using sudo-s. Check your list of add-ons again and you'll see Rancher vCluster Experimental. Before turning it on, it's worth checking a few version numbers line up. As it comes, it will deploy Rancher 2.9.3, but if we check the Harvester 1.5 compatibility matrix, we can see it requires Rancher 2.11. If we come to the three dots here and choose Edit YAML, we can change the version of Rancher that gets deployed. 2.11.2 is the latest as I record, and it's compatible with Harvester 1.5, so I'll choose that. But now we need to check the Rancher compatibility list to see if the version of K3s is supported. Rancher 2.11 is certified for K3s versions 1.30 to 1.32, so we need to bump up this version number as well. Save that and we're good to go. Click the dots, choose Enable, set it to Enabled. Give it a hostname and a password and click Save. The hostname needs to be resolvable in DNS. In my case, I created an A record for Harvester and a CNAME for Rancher that points at the same Harvester record. When you enable this add-on, it creates a vCluster to deploy a nested Kubernetes cluster running the lightweight K3s. Rancher gets spun up inside this K3s cluster to keep it isolated from the rest of Harvester. Harvester itself uses an Nginx ingress controller, so when you connect on the address you chose for Rancher, it knows to pass that connection onto Rancher instead of Harvester. You don't need to configure any of this, it all happens under the covers. You just need to choose a name and click Save. Once it's deployed, you can open up the Rancher URL and enter the bootstrap password you chose when you enabled the add-on. Once logged into Rancher, you'll see one K3s cluster called Local. This is the nested vCluster that Rancher got deployed into automatically. It's not the real Harvester cluster. In fact, so as not to confuse things, I'm going to go to Global Settings in the menu, scroll down to Hide Local Cluster and get rid of that. Okay, it's gone, so where's Harvester? Well, at the moment, Rancher doesn't know anything about Harvester. If we want to change that, we need to come down to Virtualization Management in the menu, and we can import our existing Harvester cluster so that Rancher can manage it. On the latest version of Rancher, you'll need to install this extension first. Give it a name and it's going to tell us what to do. Grab this URL, then head back over in Harvester and go to Settings on the Advanced menu. Find Cluster Registration URL and paste in the one Rancher gave us. That'll just take a moment. If we pop back over to Rancher and wait, we'll see this change to active once Harvesters come under management. Now our Harvester cluster is available under the Virtualization menu with Rancher and we can manage it all from here. But these are all the same options we had directly in Harvester, and there are still no Kubernetes clusters showing up in Rancher. There's actually a nice little integration here. If you click Create to deploy a new Kubernetes cluster using Rancher, it can automate the deployment of virtual machines to host Kubernetes using the Harvester cluster we've brought into management. But that's not what we wanted to do. We wanted to bare metal everything on a single host in our lab. To do that, select Global Settings from the main menu, then choose Feature Flags. There's one last experimental feature to turn on, the Harvester bare metal container workload. Activate that, look back in the Rancher menu, and finally we see the Harvester Kubernetes cluster. If we click into it, we can probably see why it's experimental. Now we've brought the Harvester Kubernetes cluster itself into management, we can see the pods and containers running within it. We could probably do a lot of damage to our setup by messing with the wrong things here. We can deploy our own containers manually, or if we go to Apps and then Charts, there's a bunch of pre-packaged apps in the form of Helm charts we can install. Casting K10 from Veeam might be an interesting one to use. It's a Kubernetes native backup application, and it will discover and back up your Harvester virtual machines as well as the more traditional Kubernetes workloads. It's on my list of things to play with, although it's worth noting that Harvester does come with a basic backup capability built in. One other thing that's worth noting is that once you've got your Harvester Kubernetes cluster showing in Rancher, you can also manage the underlying Longhorn storage cluster. In this single machine home lab scenario, That can be useful to get rid of the warnings that appear if you look at the volumes in Harvester. Bearing in mind Harvester expects to be part of a multi-node cluster, these warnings won't disappear until you've got it spread across at least 3 nodes. If I follow this link in Rancher to open the Longhorn interface, I can select them, choose Update Replicas Count from the menu, and set it to 1. And now they're all healthy. If you're running this in production, of course, you probably shouldn't do that. But if you're running this in production, you probably shouldn't do most of the things in this video. This is just me playing in a lab, okay? Speaking of my lab, it's time to answer that question about resources. Does Harvester really need 32 gigs of RAM just for a test deployment along with 8 CPU cores? Well, not exactly, but also kinda yeah. The couple of instances I've used to capture footage for this video both had 16 gigs of RAM, so 32 is clearly not required to install Harvester. So actually, partway through recording this, I upgraded from Harvester 1.4 to 1.5. 16 gig was enough to install 1.4, but 1.5 couldn't quite make it. I installed 1.5 using 22 gigs and dropped it back down to 16 gig once installed, and that did work. That said, 16 really doesn't give a lot of room to play. A barebones Harvester install doing absolutely nothing consumed just under 10 of my 16 gigs of RAM, and the CPU was not exactly idling even with 8 cores. I found that on a quad core, it wasn't even possible to start a single virtual machine because Harvester reserved every single core for itself. Once I enabled Rancher and switched on performance graphs, it consumed 11 gigs of RAM and most of my CPU. This is still without any actual workloads. Compare this to Proxmox in the same hardware which consumed 1.25 gigs of RAM, Hyper-V using just under 1.5, or ESXi weighing in at 1.75. All of them are under 2 gigs, making Harvester considerably more resource hungry. Now 10 gigs is not a massive amount of RAM in the context of data center hardware, but for my intended use case it is a bit of a problem. The attraction of running everything on bare metal with a single host was mostly so I could play with Kubernetes whilst conserving resources in my lab, but realistically I'd be better off with a more traditional hypervisor and something like K3s in a virtual machine. That would consume fewer resources, and when I'm done and want to play with a different technology, I can just delete it. Even though it's probably not a good fit for my needs, I still think Harvester is a pretty interesting platform, and it is worth noting that my intended use case is not what Harvester was built for, so it's not like it really failed or anything. In fact, the comparison to VMware ESXi isn't exactly a fair one, because Harvester isn't just a hypervisor. It would be fairer to compare it to VMware ESXi, plus vCenter, plus vSAN, and plus Tanzu as well if we're talking about Rancher and containers. But I always like to hear what you guys are doing. So if you've played about with Harvester, drop a comment and let me know how you found it. I'll link everything in the video description so you can have a play about with it yourself. While you're down there, it's YouTube, you know the drill. Give the video a like and share it with anyone you think may find it interesting. Make sure you're subscribed and I'll see you at the next one.